Well, welcome to another great lesson on rationals. Our focus tonight is going to be on solving rational equations. So let's just review. A rational equation is an equation with a ratio. So we'll start with some simple rational equations, something you might have tackled back in Common Core Algebra 1. So a simple rational equation basically has one ratio on each side. So can you think of what would your gut say? How do you think you might solve this problem? You have a fraction or a ratio with an equal sign in between. Hopefully you've guessed at it by now, and you're saying, okay, I've seen this a million times. I'm just going to cross multiply. So I'm going to say that's 2 times x minus 1 equals, and then we'll go this way, 5 times 4x plus 5. And we'll just go ahead and solve that equation. This is a simple rational equation. So that's 2x, we're going to distribute minus 2 equals 20x plus 25. Obviously I want to solve for x, so I'm going to put my x's on one side, subtract 2x from each side. So that leaves me with an 18x. And I'm also going to subtract 25. So I'm going to get a negative 27. So maybe not the most beautiful number, and that's okay. We should be used to that by now in Algebra 2. I'm going to say x equals negative 27 over 18. Now, perhaps you're thinking you can reduce that. You're definitely right. 9 goes into both of those. So 9 goes into 27 3 times, into 18 twice. So there we have it. We've solved a simple rational equation. If only life were all about the simple things. So of course it's going to get a little more intense because that's what we did in Algebra 1. So before we jump into the really intense equations, we better just practice finding common denominators. So I'm going to start with example 1. A common denominator means I need the same on each denominator. So notice these are all monomials. They are all one term. Okay, there's no plus or minus. Each denominator is one term. So if I look at the numbers 3 and 6, I need a number that they both go into. So I'm thinking 6 works. And then I need a number that k squared, and k go into. And I would say that's k squared. So I'm going to say my least common denominator is 6k squared. Let's take a look at number 2. Okay, so again, they're all monomials. They're all one term. So I'm going to need one term for my least common denominator. So I'm going to look here. Number-wise, I definitely need the number 2. Variable-wise, I need an n squared and an n squared, so I would say they each have an n squared. I can make each one into 2n squared. Let's see, I'm going to skip those 2 and come down to 5 here. Notice this one isn't a fraction, so I'm going to put it over 1 to make it a fraction. Again, each of these are monomials. They are one term. So my least common denominator is also one term. Number-wise, I need a number that 5 goes into, so 5 works as my least common. And I need an x, so I'm going to call my least common denominator 5x. Now I'm going to skip to some little more intense ones here. Number 7. Notice I have a monomial and a binomial. That means I need to have 2 common denominators, one that's a monomial and perhaps one that's a binomial. Now the other thing you'll notice is that we can factor this. So I'm going to go ahead and factor. I can GCF, I can pull out a v. I've got my v minus 5. And on this one I can also pull out a v and I have v minus 5. I'm going to rewrite that. And this guy still has a denominator of just v. So as I look at the monomial, the one term, I need a v here. And notice they all have a v, which is awesome. And then I need the binomial v minus 5. So I'm going to say my least common denominator is a v and a v minus 5. Let's do the same on number 8. Okay, so again, I have a monomial and a binomial. I'm going to need 2, but these can get factored, so let's clean them up and factor. I'm going to pull out a nice GCF. M and m minus 1. This guy's still an m, and this guy factors also to m and m minus 1. So my least common denominator, my monomial, my single term, is going to be m, and my binomial is going to be m minus 1. Okay, I need one of every term that I see. I'm going to skip down to number 10. This one is just r minus 2, so it's a binomial, is what it is. This one's r minus 2, is what it is. But notice this guy can get factored. I've got a little trinomial factoring. So r and r, remember multiply, add, multiply. I'm thinking minus 5 and minus 2. So now as I look at these, I have a binomial, and two binomials. So I won't need a monomial, I'll just need the binomials. So my least common denominator, I'll need an r minus 2, and I'll also need an r minus 5. All right, so here are the steps to solving a rational equation. So more than just that simple cross multiply. So make sure you jot these down. Identify what makes each fraction undefined. So we've talked about that word earlier this week, and of course that means when the denominator equals 0. Identify the least common denominator, which we've done this week as well. Rewrite each fraction with the same denominator. Now here's the different part from adding and subtracting. We are going to cross off the denominator and solve the numerator. And then of course, the big fat old check, and we'll cross off any extraneous roots. And those are just roots that don't check. All right, so here's our first real example. So this one is not simple like the old cross multiply. So if you look back at your notes that you just copied down, we first want to talk about what makes each fraction undefined. And before I even do that, I'm going to factor any denominators that need factoring. So I have x plus 1 over x plus 5 plus 18. This bear here can get factored. Again, trinomial, multiply, add, multiply. X and x, let's see. 5 and 3, x plus 5 and x plus 3. And then I've got equal 9 over x plus 3. So let's maybe make a note. Let's put a nice little star there, and let's go factor first. Make sure you factor those denominators. I guess I didn't put that in the directions because I thought that was kind of implied from our past few days. But let's make sure we factor first. Okay, so let's talk about what the x values cannot be. What makes this fraction undefined? Okay, so hopefully you're pretty good at this by now. X cannot equal negative 5. Okay, obviously I would set that equal to 0. Also, this one x can equal negative 5, but in this one x cannot equal negative 3. And in this one x cannot equal negative 3. So why is that so important? Well, if I get one of those answers, they automatically get rejected, and I don't have to waste my time. All right, we're now ready to identify our least common denominator. So this fraction has an x plus 5, and if I compare, it's missing the x plus 3. This one has both, and this one's missing the x plus 5. So my least common denominator are both binomials. Remember, you need one of everything that's out there in the denominator. I need an x plus 5 and an x plus 3. So now our goal is to rewrite each of these fractions. So I have x plus 1 over x plus 5, and we just said we have to multiply by that x plus 3. Okay. Then I've got my plus sign. Now, you'll notice this one already had both x plus 5 and x plus 3, so I don't need to do anything to the top. We'll just leave it. This last term only has the x plus 3, so it has to get multiplied by the x plus 5 over x plus 5. All right, so if you look back at your directions, we said we wanted to rewrite each fraction with the same denominator, and that's what we did. Now, the next step says, once they all have the same denominator, and because this is an equal sign in equation, we are literally going to cross off the denominators. And we're just going to solve for the numerator. Okay, now, these are two binomials. We have to FOIL them out. So I'm going to say that's x squared plus 3x plus x plus 3. And I've got plus 18 equals, that's 9x plus 45 as I distribute. Okay, we always want to set our quadratic equal to 0, so that's x squared plus 4x plus 21. And I'm going to subtract over the 9x and subtract over the 45. So that's x squared, put those terms together, minus 5x minus 24 equals 0. Okay, so now I'm going to factor and solve. So trinomial, multiply, add, multiply. I'm thinking 8 and 3, and I'm multiplying to a negative, so the signs are different. And I need to add to a negative 5, so I would say that's negative 8 plus 3. equals 0, tee it up. X minus 8 equals 0, x plus 3 equals 0. So x equals 8 and x equals negative 3. Now remember, it's an equation, so you have to go back and check your answer. But here's the beautiful part. When we stated what's undefined, we said the answers can never be negative 3 or negative 5. So I know that this answer is automatically getting rejected and that my only solution is going to be the number 8. Okay, so not the easiest equations to solve. They definitely take some time and effort, and we just got to slow down and make sure we go through the steps. All right, so let's go ahead and try another example. So again, I wouldn't call this one simple because it's not a quick cross multiply. I definitely need to take my time. So remember, we made a star in our notebook and we said, really, before we begin any of those directions, let's factor first. So I'm going to clean up any denominators that I can. So trinomial, multiply, add, multiply. So I'm going to say x plus 6 and x minus 2. X minus 1 over x plus 6. And 1 over x minus 2. All right, so step 1, we factored first. Now we have to state where the fractions are undefined. What can x not be? So right here, if I were to plug in a negative 6, I would get 0. So x cannot equal negative 6. Here, x cannot equal 2. Because remember, it's all fun and games till somebody tries to divide by 0. Here, x can equal negative 6, we've got that covered. And here, x can equal 2, and we've got that covered. All right, so step 1 done. Step 2. Let's go get common denominators. So I'm going to rewrite my fractions real quickly before I put my denominators in. Okay, so my least common denominator, notice I have 2 binomials. So that means everybody's going to need 2 binomials. X plus 6 and x minus 2. This guy already has it. This guy only has the x plus 6. It needs the x minus 2. And whatever I do to the top, I do to the bottom. This guy has the x minus 2. It's missing the x plus 6. Now life is good. All of these fractions have common denominators. We made them all the same. So that step in our notebook said then we can now eliminate the denominator and just solve the numerator. So 4 plus, again this definitely needs a FOIL, x squared minus 2x minus x plus 2 equals x plus 6. Again, when I have a quadratic, meaning a squared term, I want to set this equal to 0. So let's see, I'll combine some like terms here. X squared minus 3x, those two make a 6. And I'm going to subtract x over and subtract 6 over, so I get this side equal to 0. Okay, so I combined some like terms and I brought those two over. All right, putting some more like terms together, that's x squared minus 4x, and it looks like those will cancel. Beautiful. All right, what type of factoring do we have? Well, we've been factoring our brains out for the past few days. There's GCF, trinomial, difference of perfect squares, difference of perfect cubes, factor by grouping. I'm hoping this is pretty obvious. You'll always start with the most basic type, looking for a GCF. And if you see 2 x's, by golly, you know you have GCF. So I'm going to pull out an x. I've got an x minus 4 equals 0. Tee that puppy up. I get x equals 0, x minus 4 equals 0. So x equals 0 and x equals 4. Now for the good old check. Let's go back. Do I have to reject any of those answers? Well, the only answers I was going to reject are negative 6 and 2, and notice I didn't get either one of those. So I'm going to assume that both of those work. All right, I've got one last one for us to tackle, and perhaps maybe the ugliest of the 3 that we did here. All right, so step 1, like we said, factor any denominators that we can, and of course this bear can get factored. Again, look for the most basic type of factoring. We've got a nice quick GCF. So I'm going to say that's 1 over x and x minus 5 equals x plus 7 over x. And oh no, what do we do if we don't have a fraction? Well, that's pretty easy. You just put it over 1. Okay, so I'm going to first start by saying what makes this fraction undefined. What can x not be? So x cannot equal, well, there's 2 things here if I were to tee that up. Here, x cannot equal 0, and on this side, x cannot equal 5. if I look at this equation, x cannot equal 0, because again, it's all fun and games until somebody tries to divide by 0. So these are the two numbers x cannot be. So again, I'm going to rewrite my equation so I can make it nice and neat here. All right, let's talk least common denominator. I see two different types of denominators. I see a monomial, one term, and then a binomial, two terms because they're separated by a plus or minus. Here's the monomial again. So that's telling me I need a monomial and a binomial for my denominator. I need a plain old monomial of just x, and then I need the binomial x minus 5. Okay, so my goal is to rewrite each fraction with the same denominator. So this first fraction already has both, so I don't need to touch it at all. This fraction is missing the x minus 5. Now this last fraction, guess what? Look at it. It doesn't have anything. So it needs the x and the x minus 5. All right. So I can clearly see that all these denominators are the same. So I'm going to take my red pen and scratch them off. And I'm just going to set the numerators equal. So this is a plain old 1. This is the quantity x plus 7 times the quantity x minus 5. So there's some nice foiling. X squared minus 5x plus 7x minus 35. Okay, now I've got this minus sign, so I'm going to be real careful here. I'm going to multiply these first, and then I'm going to be real careful to distribute that negative. So I want you to take your pen and make sure you put this in a nice big color, because we need to distribute this negative very carefully. So again, I'm going to do my math here. 1 times x, cross those off, we multiply those together, and 1 times x is x. Now I have to take that x and multiply it by the x minus 5. So I would say that's x squared minus 5x. Now where's the part everybody's going to make a mistake on? It's this silly subtraction sign. You have to take this negative and distribute it. So I'm going to say I get a minus x squared plus 5x. Okay, so I would put a big star in your notebook. If you're going to get anything wrong, it's probably a silly negative sign. Make sure you take it and distribute. All right, so let's clean this puppy up. Let's see, I'm going to say 0 on this side because I'm going to subtract 1 to both sides. So I'm going to get x squared and minus x squared. Wow, those eliminate. That's awesome. Negative 5 and positive 5x. That's awesome. Those eliminate. So it looks like I get 7x, and I have negative 35 minus 1, so minus 36 equals 0. Now, all I got to do is get x by itself. There's clearly no factoring to do. I'm going to add that 36 over, equals 7x. Divide by 7, and I'm going to say x equals 36 over 7. Now I'm just going to do one quick check. Was that a number I had to reject? Nope. So even though this number is ugly, it's still going to be my solution, 36 over 7. Well, that does it just like normal. We'll have a bunch of good practice problems. If you have questions, come and ask before class would be a great method. Have a great night, and we'll see you tomorrow.